like a Hellcat.
Hi guys, so welcome back sa ating YouTube channel. So ito na yung ating lesson 11 para sa ating abstract algebra playlist. So ito na yung pangatlong lesson para sa module na to. So we have test for subgroups. So in this video, pag-uusapan lang natin muna yung tatlong theorem na importante para sa test for subgroup. So yan yung mga test na pwede natin gamitin para hindi natin dadaanan yung sinasabi ko na mag-element argument ka, tapos ipoprove mo na siya ay close, associative, hanapin mo identity, then hanapin mo yung inverse, yung recursive formula. So show mo dapat na element siya nun. Okay, so in this video, pag-usapan natin itong mga theorem. So we have theorem 2.6.1, we have the one-step test. Okay, so ito yung mas kilala as OST. So one-step test. So let G be a group, and let H be a non-empty subset of G. Then H is a subgroup of G if and only for all A and B element of H, AB inverse is an element of H. So tandaan, so for masasabi mo na subgroup si G, masasabi mo si H is subgroup G if and only for all A and B element of H, AB inverse is an element of H. So ayun yung goal natin. So kailangan natin i-prove na siya ay subgroup ni G. So paano natin siya i-prove? So dito i-write ko hypothesis niya, o somewhat hypothesis niya. Dito may sinabi kasi dito, highlight ko lang, no? For every A and B element of H, okay, then this implies, kasi comma, this implies that AB inverse is an element of H. So ito yung parang hypothesis nung ating theorem. Okay, so ito yung highlight niya. Okay, so ang gagawin natin is ipoprove natin siya throughout. So yung buong ano niya. Okay, so ngayon may dalawa tayong set dito. So meron tayong kino-consider dito na consider natin yung dalawang group. So consider this group. Consider H, asterisk and G, asterisk. Okay, where H is a subgroup of G. H is a subset of G. Okay, so ganyan ang consideration natin. Now, ang goal natin is patunayan yung part na to. Okay, so ano mga gusto akong patunayan, I mean? Kailangan masabi mo na siya ay inverse. Kailangan masabi mo na siya ay close, associative, may identity, tapos andyan yung inverse. Ayun yung mga dapat nating malaman dito. Again, dapat ganun yung mangyari dito by using this hypothesis. So, ang gagawin lang natin is ipapakita natin na siya ay close using this hypothesis kasi nga siya yung subgroup test. So dapat using this hypothesis dapat mapakita mo na andyan yung identity. Using this hypothesis dapat mapakita mo na andyan yung inverse. Using this hypothesis dapat makita mo na siya ay close. Okay? So dito sa associativity medyo it follows na kasi nga sinabi ko na pag pares na binary operation, it follows na siya ay associative. Okay? So again, proceed tayo dito. So since the operation of H is the same, so lagi ka na lang, is the same as that of G, it is clear, lagi ka na lang, so it is clear that this operation referring sa asterisk is associative. So sinabi ko naman na yan, it follows yan. So meaning hindi natin kailangan to. So ngayon, ano yung mga essential part dito? So sir, ba't ganun? Inuna mo yung pagiging associative, hindi mo inuna yung pagiging close. So again, hindi naman natin pinuprove na siya ay group. Pinapakita lang natin na nag-exist yung mga part. So alam na natin na ang pinapakita natin dapat na tama yung hypothesis na to. So ang goal natin mapakita na tama tong hypothesis to. Using that hypothesis dapat mapakita mo yung identity element, mapakita mo na yung inverse nag-exist, and lastly that mapakita mo na siya ay close. So meaning hindi ka nagre-refer na okay, dapat una yung close, una yung associative, then sunod yung monoid, then lastly yung inverse. Dapat ganun. Hindi. So dito kahit ano yung unahin ko. So inuna ko na yung associative kasi obvious na siya. Next is yung next thing na dapat nating makuha is that dapat alam mo nandyan yung identity element. Kasi si inverse, hindi mo makukuha si inverse kung wala identity element. Kumbaga, merong relationship si identity element si inverse kasi A inverse is equal to E. Ganun yung ibig sabihin niya. So ngayon, unahin is kunin natin yung identity element. So ang gagawin natin is magle-let tayo. So let x element of h such that x is equal to a and x is equal to b. So inassume ko na siya ay dalawang bagay. Now, by hypothesis, okay, so by hypothesis, we have, so ang gagawin ko, by hypothesis, we have, this implies, so like by hypothesis, ng ating theorem, so we have AB inverse is an element of H. Ayun yung sabi. Note na this implies yung x papalitan ko, yung A papalitan ko ng x, yung B papalitan ko ng x. So this is x inverse. Okay, which implies that x inverse, which implies by definition of identity, this is E, which is an element of H. So therefore, E is an element of H. So again, ayan yung ginawa kong diskarte. Naglet ako ng x such that si x is equal to A and B. Then using the data hypothesis, dapat lumabas yung E is an element of H. Therefore, E is an element of H. So meaning, yung identity element nag-exist. Now, kailangan ko naman hanapin yung inverse. So, to find inverse, to verify that x inverse is an element of H. So using the same hypothesis ulit, no? So ang gagawin natin, let natin, so maglet lang tayo, let A, so maglet ako ng A is equal to E and B is equal to X. So again, naglet naman ako ng different, so let ko na A is equal to E and B is equal to X. So using by hypothesis again, so by hypothesis, we have AB inverse is an element of H, which implies palitan natin yung A ng E, yung B ng X inverse, which implies that X inverse is an element of H. So meaning, yung inverse is element of X. Whenever X is in H. So meaning, nag-i-exist yung ating inverse element. So lastly, dapat mapakita ko naman na siya ay close. So aware na ako na siya ay may identity. Next, aware na ako na may inverse siya. Aware na ako na siya ay associative. So lastly, gusto ko naman pakita na dapat siya ay inverse, close. So close is yung A and B element of H. So now, ano ba gagawin natin? So maglelet naman ako ng different element. So ibahin ko na ng ballpen ko, no? So maglelet ako dito. So maglelet ako ng A is equal to X and Y is equal to B. Y inverse is equal to B. O palitan ko, medyo baliktad. And B is equal to Y inverse. So alam ko naman na si X element to H. So arbitrary kasi yung Y and X na yun, ha? So arbitrary. So since alam ko na si X is element ni H, andyan siya. Now, yung Y inverse, sir, paano mo sabi niyan yung Y inverse? Since inverse is nag-exist, therefore, Y inverse exists whenever Y is an element of H. So, sure ako dyan. Okay? So, now, by hypothesis again. So, by hypothesis natin. So, by hypothesis, we have A, B inverse is an element of H. Then, substitute lang natin yan. This implies that this is X, then this is Y inverse, which implies that X, Y is an element of H. Okay, so para masabing close, whenever meron kang X and Y, X, Y is an element of H. So therefore, H is close. So therefore, one step test o yung theorem na to is done. So again, ang pinakita ko lang is, ang goal ko is mapatunayan ko yung hypothesis na tama. So ano ibig sabihin, anong goal ko? Para masabi ko na tama yung test na to, o yung hypothesis na sinasabi niya, dapat gamitin ko yung hypothesis na kung saan mapalabas ko si identity, mapalabas ko si inverse, mapalabas ko na siya ay close. Na kung napapansin mo, ginagamit ko siya. Yun yung ibig sabihin niya. So therefore, one step test is done. Now let's have theorem 2.6.2. We have the two two-step test. So let G be a group and let H be a non-empty subset of G. Then H is a subgroup of G if and only if for all A and B element of H, AB is an element of H and A inverse is an element of H. So let me call this lang ha. So yung AB element of H, so that is close under operation. So meaning ng AB element of H, lagi ka lang no. AB element of H, ang ibig sabihin nito, H is close under the operation. Okay, then lastly, A inverse is an element of H, meaning H is close under taking the inverses. So, ano ibig sabihin nito or inverses? Ibig sabihin nito, kung meron kang may inverse, B inverse element of H. Yun ang ibig sabihin yan. So, meaning, kung sa A inverse element of H, ibig sabihin lang yan, close yung mga inverses. Kung A inverse, asterisk B inverse, A inverse, asterisk C inverse, close yun. So, meaning element din, nag-exist din sila sa loob ng H natin. So, sa proving na to, medyo madali siya or medyo mabilis siya kasi by the use of Theorem 2.6.1. So, proof natin, try natin i-prove or i-prove. Okay, so by theorem, so like ko na agad, so by theorem 2.6.1, so it is a pieces, to show that, so like ko na no, to show that A and B, so A and B element of H, okay, implies AB inverse. So ayun kasi hypothesis na AB inverse is an element of H. Okay, so tama yan. So by theorem 2.6, kung meron kang A and B element of H, alam natin na si AB inverse is an element of H. So ang goal na lang natin, mapakita natin na si AB element of H and si A inverse element of H. Now, start tayo dito. So we suppose that, so capital S yan. So we suppose that AB element of H, okay, AB element of H. Now, since H is close under taking the inverses, again, sinabi na sa hypothesis, A inverse, so sabi na H is close under taking the inverses. So since H is close under taking the inverses, this implies also A inverse is an element of H or B inverse is an element of H, or pwedeng and actually. Okay, so meaning nag-exist yung A inverse saka B inverse kasi nga ito yun A inverse asterisk B inverse element of H, so meaning nag-exist yung A inverse saka B inverse, so meaning okay na tayo sa inverses na yan. Now thus A B inverse is an element of H, and by closure, under the operation. So, paano ko naman nasabi? Siya ay close under the operation kasi meron kang element A, tapos kumuha ko ng element B inverse, in-asterisk ko sila. So, assuming na yung B inverse is just hindi siya, inverse. So, meaning, ibig sabihin na ito, nagdidictate lang na siya ay close. So, meaning, parang implication lang nito, siya ay AB. So, for every A and B element of H, siya ay close. Lagi siyang element of H. Okay, so arbitrary yan ha. Yung B inverse, parang i-consider mo siya ay B. So, parang ang tinitake lang niya per granted dyan is A asterisk B inverse. So, si B inverse tinitake natin as B. So, meaning, sinasabi na niya siya ay close under the operation. So, therefore, this is done. So, siisipon na ako kaka-prove ko pa. So, lastly is, we need to show this Theorem 2.63. So, ito medyo kakaiba rin. Pero, I'll try my best para mapakita sa inyo yung gagawin ko dito. So, check ko rin, hanapin ko rin yung group na yun para makakuha tayo ng magandang example. So, ang gagawin ko, ipapakita siya through example. Okay? So, consider natin dito, no? Nalagay na ako dito ng set. Consider natin si C sub 6, plus, tapos yung E is equal to 2. Kumbaga ito ay parang reference lang natin sa pag-prove. Okay, so we have theorem 2.6.3, the finite subgroup test. So actually hindi naman to nagagamit. So ang nagagamit lang talaga totally natin is si one step test kasi two step test, pero kailangan ko na rito ipakita. Okay, kasi sa finite subgroup test, ang gawin mo na lang, ipakita mo yung table ng subgroup, ipakita mo yung table ng group. Okay, kasi nga finite group lang sila eh. So, what if ipakita mo na lang yung table? So, at least nakita mo, at least mas sa ganung paraan, check mo lang, tignan mo lang yung mga element. So, nakita mo na subgroup na siya. So, ganoon na kasimple yun. So, dito nga, meron siyang theorem. So, let H be a non-empty subset of finite group G. So, again, a finite group G. Then, H is a subgroup of G if and only if H is closed. So, yun yung sabi, no? H is a subgroup of G if and only if H is close. If H is closed under the operation. So, meaning lang yan, if H is closed under the operation, then H is subgroup of G. So, yun ang ibig sabihin niya. Close lang siya under the operation. So, yun yung sinasabi ko kanina. Parang, ito. Tingin ko. So, tulad na ito. Ang ginawa ko lang, yung H na to, nakita nyo, close siya. Bakit? 1 asterisk 1 is 1, 1 asterisk negative 1 is negative 1. So, horizontally and vertically, walang naulit, tapos nagamit lahat ng element na 1 and negative 1. So, close siya. Walang lumabas. So, alam mo naman kung kailan may lalabas yung gaya ng example ko na yung may lumabas na 2, 4, yung 1, 3, 5, lumabas yung 2, 4, 6, o yung 2, 4, 0 na element. Tama. No, kung napansin mo, hindi siya subgroup. So, ayun yung mga, ito yung talaga yung hina-highlight na itong topic na to. Now, we need to prove this thing. Okay? So, paano ba natin gagawin to? So, syempre, through the use of ng mga previous theorem natin, tapos through the use ng aking illustration na yan. So, ang ginamit ko na finite group is C sub 6, comma plus or addition modulo 6, where A is equal to 2. So, ang reference natin is yung element 2 ni C sub 6, comma plus. Okay? So, gagawin natin is ipoprove natin siya. So, this is the proof. Okay? So, in view of Theorem 2.62, okay, we need only to prove, prove that A inverse is an element of H. Whenever A is an element of H. So, ayun na naman talaga kailangan natin gawin. Kumbaga, mag-usap lang tayo sa isang element. So, kumbaga, using Theorem 2.6.2, so, disregard na natin si A and B, close na yan. So, ang gawin na natin is, pakita lang natin. So, kumbaga, we need only to prove that A inverse element of H whenever H is an element of A. So, ngayon, dyan tayo gagalaw sa A inverse na yan. So, ngayon, gagawa ko na idea. Una, if A is equal to E. Dito na nga. If A is equal to E, ano yung A inverse? E po. Tama. Again. If A is equal to E, ano yung A inverse? E po, sir. Kasi si A is E, meaning, yung inverse ni E is E. So, then, pwede kong sabihin na ganito. Then, we can say that A inverse is equal to A. Tama ba? Again, if A is equal to E, then A inverse is equal to A. So, meaning, done na tayo. So, kung ganito yung nangyari, and we are done. And we are done. Okay, so arbitrary, kung A is equal to E, A inverse is E, tapos na tayo. Wala na kailangan patunayan. Hindi mo na kailangan patunayan A asterisk A, A asterisk B. So, alam mo na lagi siyang E. So, tapos na tayo. Eh, what if hindi po siya equal sa E? So, now, if A is not equal to E, okay, consider the sequence. So, the sequence of element niya. So, consider the sequence A squared, A cubed, then that. Okay, so, ano ibig sabihin ng A squared, A cubed, that yan? Ibig sabihin ng A squared, A cubed, yun yung nire-raise natin. So, for example, assuming na start tayo dito, si 2, start tayo, no? So, 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 0. Tama, no? So, 2 raised to 4, sunod ko lang, ha? 2 raised to 4 is 2, 2 raised to 5 is 4, I think. So 2 raised to 6 is 0 again. So blah 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 blah. So kumbaga nare-raise ko lang siya. So yun ibig sabihin ng a raised to 2, a raised to 3 dot. So yan yung sequence. So okay, so consider yung sequence ng element na yan, in which isang element lang yung reference natin. So kaya mayroon akong para example dyan. So now, ang gagawin ko, so by closure, lagay ko lang, no? So by closure, all of these elements, so lahat ng mga elements na yan, so imagine mo, all of these elements belong to H. So tama naman, belongs to H. So tigpansin mo, yung 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 na yan. Okay, so yung 1, so yung 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6. So assuming meron tayong H, no? So assuming meron tayong H na the set containing 0, 2, 4, 10, comma, plus din. Okay, so lahat ng yan belong pa rin sa H. Kung napansin mo, so 2 raised to 0 is 0. Sorry, mali ako dito. 2 raised to 0 is 0. Yan. Okay, so 2 raised to 1, 2 raised to 2, 2 raised to 3. Lagi siyang belong sa H. So tama yan. Okay, so okay tayo dyan. Lagi siyang tama. Now, ito yung medyo tricky kasi pinag-uusapan natin finite eh. Now, since H is finite, okay, since H is finite, not all of these elements are distinct. So tama naman. Sir, ano ibig sabihin ng distinct? Yung a squared, a cubed, dot something, hindi since alam ko na finite yung H natin, lahat sila hindi distinct. Ano ibig sabihin ng distinct? May magkaparehas. Tulad ng ginawa ko. Napansin mo, 2 raised to 0 is 0, 2 raised to 1 is 2, 2 raised to 2 is 4, then 2 raised to 3 is 0 ulit. So meaning hindi distinct. So although sequence sila, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, may mga element dyan na pare-parehas lang. Tulad ni 2 raised to 0, 2 raised to 3, saka ni 2 raised to 6. Okay, pare-parehas silang equal sa 0. Okay, so nagkamali ako dito nilagay. So this is equal sa 4, equal sa 6. Okay, so napansin mo, hindi sila distinct actually. So tama yung sinasabi ko dito. Okay, no? So since siya ay finite, not all these elements are distinct. So hindi lahat yan ay distinct. So ngayon, maglalaro tayo na. So say natin na, so say that a raised to I is equal to a raised to j. So kumuha ko dyan. So and I is greater than j. Okay, so kumuha ko, no? Say that a raised to I is equal to a raised to j when I is greater than or equal to j. So ano yung example dito, sir? Example dito natin ay si let's say si 2 raised to 4, si 2 raised to 5 is equal kay 2 raised to 2. Tama? Whenever, tas alam natin sa 5 is greater than 2 yung exponent nila. So tingnan mo, 2 raised to 5 is 4, 2 raised to 2 is 4. Equal sila. Ito yung sinasabi niyan. A raised to I is equal to A raised to J for I is greater than J. So tama yan. Tama. So actually meron pa susunod dyan eh. Meron pa mas greater dyan. Okay? So tama to yung statement na sinabi ni sir. Now, ang gagawin natin, ngayon, since equal silang dalawa, then ito yung check natin sunod. A raised to I minus J is equal to E. So paano po nangyari yung A raised to I minus J is equal to E? Check mo tong part na to. Okay, so itong part na to, itong part na A raised to I is equal to A raised to J. Mag-multiply ako dito. So ang gagawin ko, mag-multiply ako ng I, multiply ako ng A raised to negative J is equal to A raised to J times A raised to negative J. Kung baga multiply ko sa inverse. Ang mangyari dito, this is just A raised to I minus J. So kasi exponent yan is equal to E. Kasi identity element yan. A raised to J times A raised to negative J. That is identity element. Kaya ganyan yung nangyari. Okay? So that is equal to E. And since A is not equal to E, so tama naman, hindi E yung kinuha ko na A kanina dito. I minus J is greater than 0. Okay. So, paano naman yan ibig sabihin yan? So, tulad nito, 2 raised to 5 minus 2 raised to 2. Ang mangyayari dyan, we have 2 raised to 5 minus 2 is equal to E. Ano yung E? That is 0. Okay, ngayon rearrange ko lang. 2 raised to 5 minus 2 is equal sa 2 raised sa 0. Kasi 2 raised to 0 is 0. Okay, so that means that I minus j, so meaning 5 minus 2 is greater than 0. So tama to statement na to. Kasi non-identity element siya. Okay, so next is, since I is greater, I greater than 0. I greater than 1 rather. So I minus j is greater than 1. So alam natin na yung 5 minus 2 is greater than 1. So gawin ko tong 1. Okay, so since A is not equal to E, I minus J is greater than 1. So alam natin yun dyan. Okay, so tama yun. 5 minus 2 is greater than 1. So kasi 0 lang yun. So okay tayo dyan. Okay, so next na gagawin natin, thus, gagawin akong thus, ang gagawin ko, meron akong A raised to I minus J is equal to E. Okay, ang gagawin ni sir dito is gagawin ko siyang ibang element. Paano ibang element, sir? Ang gagawin ko, magmumultiply ako ng A dito sa kabila. So magmumultiply ako ng A sa left side tapos ng A inverse sa right side. Okay? So ang gagawin ko dito na lang na continuation. Magmumultiply ako ng A dito asterisk tapos A I J equal to sa, so mag-asterisk equal to sa A asterisk E. So mag-multiply ako sa left side. Okay, next is mag-multiply ako sa right side ng A inverse. So this is A I minus J asterisk A inverse. Dito naman is A asterisk E asterisk A inverse. So ginagawa ko lang. Next is anong nangyari dito? This is just equal sa I minus J minus 1. So kinuha ko lang lahat na sa left side. Kumbaga inangat ko lang din siya doon. Then this is just equal sa E. Okay, so A asterisk is A asterisk A inverse is E. So tama tayo dyan. Okay, so meaning ito yung nakuha natin na expression. So now may nakuha tayo ng ganyan. Ngayon ang gagawin ko, mag-multiply ako ng A inverse dito. So sir, ba't ka mag-multiply ng A inverse? Pag nag-multiply ako ng A inverse dito, mag-multiply din ako ng A inverse dito, tapos maka-cancel siya. Tama? So ang mangyayari, so this implies that I minus J minus 1 is equal lang sa A inverse. Okay? So ulit A minus I minus J minus 1 is equal to A minus 1. Ngayon, ito yung gusto natin malaman. Ang sabi lang, we need to show that A inverse is an element of H. So nakuha ko na yan. Tama? Meron na akong A inverse. So ito yung tanong. Yung A minus J minus 1, pag siya element ng H, si A inverse element of H. Okay? Now, since alagay ka lang, but I minus J minus 1 is still greater than or equal to 1. Tama ba? Na yung A raised to I minus J minus 1 is greater than or equal to 1. Check nga natin dito. Diba ito yung 5 minus 2. So 2 raised to 5 minus 2 minus 1 mo. So ulit gawin ka lang ha. Diba ito yung 2 raised to 5 minus 2 minus 1. That is 2. Which is still greater than or equal to 1. So tama tayo sa statement niyan. So this implies that A raised to I minus J minus 1 is an element of H. And this implies that A inverse is an element of H. And we are done. So, anong ibig sabihin na sir ginawa doon? Ang ibig sabihin ko lang, pag yung I minus J minus 1 is greater than 1 pa rin, sure pa rin ako na element pa rin siya doon. Kumbaga, element pa rin siya na is kulon neto. 2 minus 5. So, illustrate ko lang dito ha. So, we have 2 minus 5 minus 2 minus 1. Gawin natin yung ginagawa dito. 2 minus 2 raised to 5 minus 2 is 3. Minus 2, that is 2. So, 2 raised to 2 is 2 raised to 2 is 4, which is element pa rin H. Bumabalik kay H lagi. Okay? Now, since aware ako na pag yung greater than equal to 1 siya, element pa rin siya na H. Therefore, since equal sila, A inverse is an element of H. So, ang ginawa ko, ginamit ko yung A, ginamit ko yung mga sequence na number para mapalabas ko na sa A inverse element of H. And we are done. So, therefore, the finite subgroup test is done. So, ganun yung proving niya dito. So, pasensya, medyo siya mahirap. So, hoping na intindihin mo siya. So, hoping din na na-appreciate mo yung aking illustration na ginawa din. So, lagyan ko lang ito ng konting guhit para ma-isolate yung ating mga proving. So, that's all. So, sa next video, gagamitin na natin si one-step test, si two-step test para ma-prove yung mga proving problem.